while the CNC machining is finishing the last spacer backside, I'm gonna show you some manual lathe work. I haven't shown you any for a long time, so now you're gonna get something. It's not that I don't do manual work, I do it almost every day. Almost as much as CNC work, but somehow I already know it so much that it doesn't really thrill me as much as CNC machining does these days. So let me show you something. So the only thing that's unfinished after milling is the outer diameter. And let me show you first how I machine this, and then I'm gonna talk to you about the setup, which is really simple. So I have set up 630 RPM and the feed is 0.1 revolutions per 0.1 millimeter per revolution, which is 4 tau per rev. And gonna take kind of a roughing pass first. It's only taking very little off. And on the finishing pass I'm feeding backwards and feeding just a little tiny bit in, almost as little as I can move the wheel, and it's gonna leave a pretty nice finish. And this insert is especially meant for aluminum. It's really sharp. That's it. Not too bad, I think. So, now a few words about the setup. So, it's just jammed in between centers. Let me try to set down the camera somehow. Off the radio, so no copyright issues. So to loosen out the piece, I just crank out the tailstock wheel, and out comes the piece. I think it's not the worst looking spacer ever made. One more to go. They have a pretty nice fit on the center hubs. And so somebody asked me about these large 50mm spacers not having the taper for the bolt, and that's right. They really should have them. But my tool dealer is closed for the whole July for the holidays. So I wasn't able to get a 60-degree chamfering tool, and none of my tools that could do the taper were not long enough to reach into the bottom of the hole. But on the rest of the spacers, I just used a 10mm ball end mill to kind of 3D profile the taper in there. So I think it actually came out pretty beautiful as well. It's not perfectly smooth, but that doesn't matter. So I think it's a pretty nice set, and there's still one more to go into the machine. And by the way, about this setup, I think this is the most accurate way to hold pretty much anything that has a accurate hole going through it. So I have a taper on this side and a taper on this side, and then I just jam the piece in between lightly, and that should give pretty much zero run out. And of course you have to take very light cuts, because the only thing transferring the rotational force is friction, and there's not very much of it, so you have to be careful. But for finishing work like this one, it works beautifully. And about the runout of these pieces, when you chuck one here and indicate on either side, it gives a little bit of runout, like 1500 or like 7000. But that's because I used a lathe chuck to hold the piece on the rough OD, and the thickness actually is within maximum 300ths of a millimeter, or a bit over 1,000th of an inch. But what causes the runout is that the upside and the bottom side are slightly out of align. It's like a 10,000th tenth of a millimeter, or 4,000ths of an inch, and that causes the piece to kind of wobble in there, even though the thickness is equal. And what it does when you put the spacer in a vehicle, it produces about the 1/10 of a millimeter, or 4,000ths of an inch of radial runout in the wheel, which is absolutely nothing. So even though it doesn't show zero every way in this setup, it really is very, very accurate. I think what's more important is that it doesn't, that the thickness doesn't vary, because if it varies a little bit here where the edge of the tire is, it's a lot already. So, and I'm just using the lathe chuck to hold it, because it's not perfect, but it gives results easily good enough. It's very fast to just hold on the body of the rough stock, and the stock really isn't that rough at all. It is pretty round. So I'm really happy with the results, and happy with the setups that I used, and pretty much happy with the whole job. Still have to make some steel washers to go under there to be able to use some hex cap screws. So, okay, thanks for watching.